these triangles congruent? We have side, angle, side. We have side, side, side. And we have now the HL theorem. Okay, so if I'm going to prove that either one of these are congruent, I got to use one of those three. So look at those pairs and see what you think. All right, so here we go. As I look at these two triangles here, this is a side, okay? This is an angle, this is a side. The angle is between or touching both of those sides, okay? It goes in order, it matches that path. Side, angle, side. So as we go around this triangle, those are the three pieces I know. This triangle is exactly the same. Side, angle, side. The angle is between or touching both of those sides. So as I look at this one, that should be side, angle, side. I can't do side, side, side because I would need the third side. We don't know the third side. Why could I not use the HL theorem? It's not 90 degrees. You got to have a 90-degree angle, okay? So the only one that would work would be side, angle, side. There are some that might be more than one, okay? And so there might be some where you could do more than one theorem. But this one, side, angle, side, is the only thing that works. Okay, as I look at this one here, okay, if you look at your pieces, we have how many pieces marked? We have two pairs of sides, and what else? An angle, okay? So do we have three pieces? Yeah, and that's one you have to have. You got to have three pieces, but three pieces is not always enough. It has to be the right three pieces, or the correct three pieces. So if it's going to be side, angle, side, where does the angle have to be? It has to be DNA. It has to be between the two sides. It has to be the angle that touches both of these sides. This angle does not touch both sides. It only touches this side here, not this other one that we know. Okay? Or if I was going to do side, angle, side, and this was the angle I would know, then I would need to know these two sides down here. So can I use side, angle, side? No. And that's the part that's kind of tricky here, guys, because we do have two sides and an angle, but the angle's not in the right spot, okay? I don't have the correct pieces here. Can I do three sides? Side, side, side?
No.
No, because we don't know the bottom side, right? Can I do the HL theorem? No, because we don't have 90-degree angle, right? So none of those three work. And so based on what we knew from Friday, we would say no. These are not congruent. Do they look like they could be congruent? Yes. Does this mean that they're not congruent? No. We just can't prove they're congruent, right? There's a difference here. When you say no, that we're just saying we don't have enough to prove it. We're not saying those triangles really aren't congruent. We just don't have enough to prove they are, okay? And that's the big difference here and when we do this. Okay. Over the next week and a half, we're going to be doing a lot of work with triangle proofs, okay? And today we're going to talk about the last two ways to prove triangles congruent, which are angle, side, angle, and angle, angle, side, okay? So we now have, or after today, we will have 5 different ways to prove triangles congruent, okay? And so we got a lot of different ways now that we're going to be able to prove triangles congruent. And we have to kind of exhaust all 5 of those options before we say no. Kind of like we did on this last one. We went through all the 3 that we knew. None of the 3 worked, so we said no. From now on, after today, we're going to have to exhaust all 5 options before we say no. Okay? I can't do it any of the 5 ways, so we can't prove the triangle's congruent. Okay, when I do the first one, angle, side, angle, it's kind of like side, angle, side, except we have 2 angles and a side, okay? And when it's angle, side, angle, you got to know the side between the 2 angles. Okay, and if you follow the path here, once again, we have an angle, we have a side, we have an angle. You're just following it in order, okay? And it doesn't matter what triangle you go to, but they have to be in that order. The side has to be between the two angles. We call that the included side. Okay, if it's angle, angle, side, notice where the side is. The side is not between the two angles. The side, it could be this side, it could also be AB here as well. Maybe I know AB and DE are congruent. Either one of those would be fine. Okay, so as I look at that, those are my last two theorems. Okay, we have 5 different ways of proving triangles congruent. Today, we're at day 1 today. We're just kind of look at triangles and try to determine if they're congruent. Tomorrow, we're going to get into more of the proving part of it. And then all 5 angles, or all 5 theorems will be in play to try to determine what we're going to do. Down here, these are kind of hard to see, so I'm going to zoom in just a little bit so we can see it a little bit better. We have this one here. And there's a lot of triangles in this picture, so you have to be sure which ones we're talking about. Well, we're looking at the ones that have markings on them. Okay, so these are the 2 that we're looking at. I'm going to outline them in red so we can see them a little bit better. Okay, we know that this angle and this angle are congruent. We know that this side is congruent to this side. How many pieces on those 2 triangles are marked? 2. Okay? Is 2 enough? No, 2 is never enough. 2 pieces is never going to be enough. But just because that's all that they give me, that doesn't mean we're done. Okay? Because there are some things that we talked about last week that I can prove without them telling me. Okay? The 2 most common, I should say, ways of proving things are reflexive property and vertical angles. There's some other things out there, but those are probably the 2 most common that you don't have to be given any information to use either one of those theorems. Okay, if I have vertical angles, I know they're congruent. If I have a shared side, I know it's congruent. So as I look at this, do these 2 triangles have a shared side between them? No. That means they have a side in common between the both. This one does not have that. Do these 2 triangles have vertical angles? Yes. So what we're going to say here is that this angle is congruent to this angle. We know that vertical angles are congruent. Okay, so we now have 3 pieces, and what we got to make sure of is, are those 3 pieces enough? Well, if we follow the pieces, we have 2 angles and a side. Okay, and some people like to start at the side. Okay, and I get that. If we did, because that's what we've been doing for the last week or so, but if I went in order here, this would be side, angle, angle. Well, we don't have a side, angle, angle. But if I reversed and went the other direction, what kind of piece do we have right here? Angle, angle, side. So is the side between the 2 angles? No, we don't know this side. So it's angle, angle, and then a side. The side is not between them. So we would say these 2 are congruent because of angle, angle, side. Okay? Any questions about how to label those and mark them and identify which one it is? Okay, let's look at this one. All kinds of triangles in here, but we're looking at the 2 triangles that have markings in it. Okay? So as we look at this one, do we have 3 pieces marked? Yeah. Okay. So that means they must be congruent, right? Because we got 3 pieces? Not necessarily. 3 pieces is not always enough. So you can't just look at it and say, oh, 3 pieces, so we're good. Okay. This one, what are all 3 pieces? Angles. Do we have a theorem that's angle, angle, angle? No. Doesn't exist. We will never have an angle, angle, angle. Not for congruence anyway. Okay. So 3 angles is not enough, ever, when we do congruency. Do I know any sides here that are congruent? Can I prove any of these sides congruent on this triangle to this triangle? No. We need some information. Like for instance, if I told you that this point was the halfway point of this segment, then I could say these 2 are congruent. Okay? I need some given information. I need a little bit more. I don't know any of that. Okay? So right now we would say not enough info. 3 angles won't work. You need at least one side. You can have two sides, but you have to have at least one side. Three angles will never make triangles congruent. Okay, on this one here, I'm going to outline this one again. Okay, we know, and let's do this one. We know this angle and this angle are congruent. We know this angle and this angle are congruent. Okay, so right now, how many pieces are marked? 2. Okay, we need 3. I need one more piece, if I can prove it, that has to be congruent. Well, what do we, as these two triangles are drawn, what do we recognize or what do we see?
We need a side.
They share a side, okay? And we need a side, right? So this side right here, this triangle and this triangle share the side that goes right down the middle. Lucas, you listening? Okay. So what can I say here? Do we have a side that we know?
Yeah.
Yeah? So we're going to say this piece right here is congruent to itself. It reflects the property, okay? And I'm going to write that here. That's why we know that. They share a side. Okay, so as I look at the pieces, is this side between the two angles? As I look at the triangle on the top, this one up here, I have a angle, and then a side, and then an angle. So the side is between the two angles. So we would say that these two are congruent by angle, side, angle. Okay, you see the difference between this one and the first one? How this one, the side's between it, and this one it's not? Does that make sense? How those two are different? Okay, here's what I want you to do. On the next page, you have 5 different pairs of triangles. I want you to tell me, are these triangles congruent? And you might just go ahead and put all of these at the top. From here on out, bless you, these are the 5 ways that we're going to be able to prove triangles congruent. So if you're going to prove it, you have to use one of those 5 things. So you have to kind of exhaust all 5 options before you say yes or no. So I want you to look at these 5 pairs and either say yes because of angle, side, or no because there's not enough information. I'll give you a couple minutes to go through that. Although all 5 of them. Oh, it's 100%? All right. Yep. Yeah.
Okay.
All right, let's go through these. Number one, this one here. Okay, do we have three pieces marked? Yep, okay. And then we got to decide the path or the order that we're going to go in. So on this one here, what do we got? Angle, side, angle. Okay, over here we have angle, side, angle. Are those two triangles congruent? Yes, and we would say they are congruent because of angle, side, angle. Okay, and that's it. That's all you got to do. Okay. Now, and this is the one that gets a little bit tricky, I think. This, out of all five of them, this might be the one that's the trickiest because when I see a 90-degree angle, my first thought is HL, right? Because we see a 90. When it's a 90, that doesn't mean you have to use HL. I can still use any of the other theorems. But in order to use HL, you have to have a 90. See the difference between that two? All squares are rectangles, rectangles are squares. It's not the same thing, right? So, kind of the same idea, okay? If I'm going to use HL, I got to have a 90, but just because I have a 90 doesn't necessarily guarantee HL. And this is not HL because AC and DF are the hypotenuse, and we don't know if the hypotenuse is congruent. The hypotenuse is not marked, okay? So we can't do HL here because we don't know the hypotenuse. But do I still have three sides? Or three pieces, I should say. Yes. We have angle, side, angle on both. Angle, side, angle. So, once again, this would be angle, side, angle. And it goes in that order. Sides between the two angles. Okay, on this one here, do we have three pieces? Yeah, okay. So, because we have three pieces, that means they must be congruent, right? Not necessarily, because what do we always have to have? Got to have at least one side. You can never have triangles congruent unless you have at least one side, okay? Here, all we have is three angles. Can I prove any of these sides congruent? No, okay? And these two, because they're not touching one another, if these were like up against each other and they shared this side right here, then we could say reflexive property. But because these two triangles are separated, then they're two completely different triangles. And we have no way of knowing if this side and this side are the same length, okay? They look like it, okay? And they probably are, the way they're drawn. They look like they're pretty close. They look like they're congruent, but we just have no way of saying, yep, absolutely, these are congruent, okay? So here what we would have to say is, no, we need a side. Got to have at least one side. And we don't have that. And there's no way to prove that. Okay, on this one here, I think it might help to redraw the two triangles that we're looking at. The bad thing about doing that is that sometimes your picture may not look exactly like it is. Try to draw it as close as you possibly can. Now, this one is MNQ, and this one is MQP. Okay, and the reason I'm redrawing them is because a lot of people think this triangle and this triangle are the ones we're trying to prove. And we could do that in some cases, right? But I'm not doing that one because on that one, all I know is this angle, and I would have vertical angles, but I don't have anything else on those two triangles. Okay, so in some cases we might do those two sometimes, but I would need to know more information. So as I look at this one, and here's the other thing about drawing this a little bit differently. Q, there's two angle Qs here. This is the smaller angle Q, so make sure you label the right angle Q. And that's congruent to this angle M over here. Angle N and P are congruent. So right now, we have two pieces on those two triangles that are marked. Two pieces enough? Never, okay? 2 pieces is never enough. I gotta have a third piece. Is there a third piece I can prove congruent here? Okay, which one? MQ, right? How can we prove that MQ is congruent to MQ? It's the exact same side, okay? These two triangles share that side. MQ is the same exact side on both of those triangles, okay? It is shared between both of those. So if I was going to label this one, is the side between the two angles? No. Okay? So we're going to start right here. We're going to start with this angle. Angle, and then another angle, and then a side. So when I label this out, angle, angle, side. That would be my theorem. Okay? Some of these might have more than one in some cases. But like I think there was one on the notes that I did the other day that you could use all 3 of them. I drew one separately, if you watched the video from Friday, and you could have done any of the 3 theorems. So sometimes you could do more than one. But on the ones we've done here so far, there's only been one way to prove it. Okay. If these two, what do these arrows tell me? That they're parallel, okay? Does that mean that they're congruent? Not really, okay? Could they be? Probably, maybe, right? But right now we don't know that to be true, okay? We would need to know a little bit more information. So right now all we know is these two are parallel, we know these two are parallel. We don't have any information that is marked other than the parallel sides, okay? So right now, how many pieces are marked? 0. We have nothing, okay? So what could be one piece of information that I can conclude? YW is shared, okay? So I would say WY is congruent to WY by reflexive property. Okay, so now we have one piece. One piece is definitely not enough. We need 2 more pieces. What do parallel lines tell me? Well, when we saw parallel lines earlier in the year, we saw it more like this, right? And we had a transversal. And it's the same idea here, except it's in the form of a 4-sided figure. And then we have like this diagonal cutting through it. So what angle could I say is congruent to angle 1? 3. How come? Alternate interior angles, good. Angle 1 is congruent to angle 3. And what other 2 angles would be congruent? 2 and 4. And we would say, because these are alternate interior angles. Okay, and as I look at the picture then, 2 and 4 are congruent. Okay, I now have 3 pieces here. So I start down here. Somebody said, well, how do you know where to start? You really don't, okay? But I'm just going to start with one of the pieces. And if I go in order here, I'm going to go in order of the pieces that are marked. So I have an angle, I have a side, and I have an angle. If I would have started up here, I would have an angle, I would have a side, and I would have an angle. So does it matter what side I start on? Not really, okay? You can start with the one that's marked first, or with 1 marking, or you can start with the one that has 2 markings. But the most important thing here is that the side between the 2 angles is the one that's marked. So it has to be angle, side, angle. Okay, and that would be our proof. Okay, for your homework today, 2 parts to your homework today. While you have your book open, we're going to do page 53, numbers 1 through 10. Okay, page 53, numbers 1 through 10. All you have to do is tell me, are the triangles congruent and why? What theorem can I use? Okay, you're going to say angle, side, angle, 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 side, one of those. And I don't think there's any HLs on that one. It's not listed at the top anyway. So I don't think there's any right angles. Well, I guess number 6 has a right angle, but none of the others have a right angle in it. Okay, so all you have to do there, and we're gonna go through that one tomorrow. So I want you to do that one before tomorrow. Okay, that's not for a grade, but we're gonna go through it. So I want you to do it just so you have some practice identifying why triangles are congruent. Okay, and then you have a big ideas. So probably do that first, while your book is open. And then when you get done with that, then you can do 5-6 day one on big ideas. If you need help with Fridays, let me know. I can help you with Fridays as well. Okay, if you have any questions on anything from Friday.